Hello guys, welcome back to session number 4 of the series. Now previously we looked at an overview of industrial proximity sensor. In this session we are going to cover the capacitive proximity sensors. We are going to look at how they are constructed, their working principle, their wiring, and some scenario based application. So let us begin. Now, these capacitive proximity sensors are present in other shapes as well. However, this cylindrical capacitive sensor is the most common shape found on the industrial environment. Now, externally, the body of the sensor is threaded for housing or mounting purposes. On the back, you will find the power signal wiring or a connector of some sort for IOs, inputs and outputs. Moreover, you will also find a LED indicator somewhere on the back end. Now, this acts as a visual feedback in case of an object detection. Also, you might find a sensitivity adjuster. Now, if the object is farther away and you want to increase the range of the sensor, you just dial down onto this potentiometer and the range of the sensor is increased. This is done for the fine tuning of the capacitive sensor sensing possibility. On the front side is the sensor face, now base sensor element as defined in the picture. Now, this is the part that generates the electrostatic field. The mounting of this sensor is quite simple. They can be screwed into a threaded hole, or these are also equipped with these securing nuts. Now, what you do is you drill a hole on a cover. The dia of the hole should be slightly bigger than the dia of the sensor, but it should be smaller than these check nuts. So you remove one of these check nuts, you insert the sensor from the hole, and you insert that check nut back and tighten it. And voila, now your sensor is properly mounted. The capacitive proximity sensor, they work on the principle of capacitance. Now, it is the ability to store charge. It relies on the distance between the plates and the dielectric properties of the medium in between. Based on this, there are two main technologies that define the capacitive sensor. Number one is conductive type. In this, one of the plate is inside the capacitor, right? While the target object acts as the another plate, acts as the second plate. In the second type, both the plates are inside the sensor sensing part, while only the electrostatic field leaks out of the sensing phase. The principle is simple. The oscillator circuit that is found inside the sensor is responsible for generating this electrostatic field. Now, as the target approaches this field, it is detected by the oscillation circuits, the electronics of the oscillation, and at a certain threshold, a certain output is generated by the sensor output circuit. Now, operationally, there are 2 points that need to be kept in mind. Number one is the operating point. Now, this is the optimal distance at which effective detection of object can be produced. And somewhere, if you move the object farther from the sensor, there comes a point beyond which the object is not detected, right? So, this is known as operating point, and this is known as release point. The in between zone is known as hysteresis zone. Now, this hysteresis zone defines the sensing range of the sensor, right? Now, typically, as I already told you, it is around 1 to 2 inches, right? So, and another thing that I forgot to mention is that these capacitive sensors work on every kind of material, metal or non-metal, plastic, fiberglass, any type of material that needs to be detected can be detected by this capacitive sensor. The only limitation is of the range. So in the next slide, we will see that how these are wired. So let us start from the basics. The capacitive sensor can be found in two-wire topology, three-wire topology, and a four-wire topology. Now, in two-wire, the sensor acts as simply as a NO or NC switch, right? You apply power on the brown wire, it can be a positive or it can be a negative signal. And after the detection, depending on the state of switch, this power is returned after detection or it is stopped after detection. So based on this, it acts as a simple switch. Now, in the case of three wire, there are brown, blue, and black. Remember, brown and blue are power wires. The brown is always positive and the blue is always negative, whereas the black is the signal wire. However, here there are two technologies. Number one is PNP and number two is NPN. Now, depending on the type of sourcing or syncing of the sensor relative to the controller, you can use either of these. For example, if you are using a the PNP signal always gives a positive signal from the black wire. So for connecting an electric load, you require a negative signal. And in case of NPN, the signal wire generates a negative output, a 0 volt output, and you require a positive signal for the electric load to be operated. Now, depending on this, there are four type of three wire uh, proximity sensor. There is NPN-NO and NPN-NC. Also, there is PNP-NO and PNP-NC. In the case of four wire sensor, the working is quite similar, but now we have two signal wire. One is black and one is white. Now, black is always going to be NO and white is always going to be NC. So, we have simply an NPN, NO, and NC in which these signal wire generate a return path or a 0 volt signal. And in order to operate an electrical load via the sensor, you require a termination with the positive side. In case of PNP, NO, and NC, the signal wire generates a positive signal and the electric load requires a negative signal for their return path. You can also look at this picture right here for further understanding. Now, these are the actual wiring scheme of a four wire PNP signal. As I told, PNP generates positive signals from their signal wires, black and white. So brown is always going to be positive, blue is always going to be negative. Now, this is PNP, so we know that the signal wire are going to be positive. So we terminate the electric load with the blue wiring or the negative side, right? Now, black is always going to be NO, right? And white is always going to be NC. So depending on your requirement, you can either use the NO switch or the NC switch. This is the NPN. Brown is always positive, blue is always negative, and the electric load is of NPN type, so it is going to be connected to with the brown side or the positive side. The signal wire is going to generate the negative part. So let us see some of the applications of the capacitive proximity sensor. Now they are ideal case for controlling level of particles or liquids. For example, I work in a pasta department, so we use floor silos. And for detection of the presence of floor in a certain area to a certain level or to in a certain hopper, we use capacitive proximity sensor, right? Number two is that they are versatile. They work with mostly all objects. It can be plastic, metal, non-metal, any sort of material can be detected by the capacitive proximity sensor. Another thing that you probably didn't know is that the capacitive proximity sensor allows through detection. For example, if the dielectric properties of the fill material, for example, in this case, milk, is greater than the body of the container, then the sensor can simply ignore the container and detect the level of the milk. Now, this principle can also be used for checking non-conformities. For example, this is a milk carton, right? If the carton is empty, and the sensor detects this, it will discard this, right, and allow the only the fill product to pass. Also, this is similar principle. As you can see, there are boxes, and inside the boxes are metallic or some material that have higher dielectric, and this capacitive sensor, which as you can see is not in the typical cylindrical shape, it is more a circular disc. So this sensor can see if the metal is present inside the box or not, and it can generate the appropriate response. So these are some of the typical application of the capacitive proximity sensor. In the next session, we are going to discuss the inductive proximity sensor. We are going to see their construction, wiring, working, etc. So see you in the next one.